Alrighty, welcome everybody back. We are doing the final part of how the web works, the pre-security module. We are in the room putting it all together. So we're learning how all the individual components of the web work together to bring you access to your favorite websites. As normal, we do have a nice little video put on here by TryHackMe. So let's go ahead and get right into it. So in all of our previous modules, we learned quite a lot of things are going on behind the scenes when you request a web page in your browser. um, Quick summary: your browser is requesting a website, then you're resolving the IP address of the web server along with DNS, then it's connecting to the web server, and then you get to view your website over your browser. This room is going to go over a couple other components uh, that's just extra things that are going in between these steps. So high level, this is it right here, but we're going to start introducing load balancers, web application firewalls, and things like that. Let's go ahead and hit complete. All right, so first, the other components, we're going to talk about load balancers. So load balancers, if you want to take a stab at what you think they do, they balance the load of traffic that's hitting web servers and other devices. So when we have a website that's being hosted out to the internet, the amount of bandwidth that I can actually take, there's a couple factors. One of them could be just simply what is that web server actually being hosted on? How much resources does it have available? Can it actually process all these requests? And for a lot of websites, it is not feasible. Websites, web applications, it's not feasible to have one device doing that. So for these bigger, more complicated, more demanding websites, you can have multiple web servers issuing out this same website or web application. And you'll have a device in front of them that's called a load balancer, because a load balancer is going to allocate traffic and requests according to algorithms, whether it could be a round robin algorithm where it's just going down a list saying, you got this request, you get the next one, you get the next one, or weighted where it checks and actually says, okay, servers one and two are being, they have high utilization. Server three doesn't. So let's put some of these requests and push it over to server three while one and two are dealing with their current load. So that's one thing that load balancers can do. Another thing that they can do is they can perform what's called a health check, which is just sending out signals to the servers to say, hey, are you good? Are you still responding appropriately? And if they're not, it knows not to throw and allocate more resources down to that server until it gets back up. All right, so it could just be it's too busy, or it could be it's down for maintenance. You know, you don't want requests going to a server that is down for maintenance, because then we'll get some of those status code errors that we went over previously. All right, so that's what we kind of need to know about load balancers right now. Moving on to content delivery networks, or CDNs. CDNs exist so that static files can be served for your requests in a very efficient manner. All right, so this content delivery network might consist of thousands of servers all around the world geographically, and it's solving the issue of, if I'm on the west coast of the United States and if I'm asking for a website, and if somebody is in Germany asking for that same website to load up the same images, the person in Germany is not trying to hit a server in California, and I'm not trying to hit a server over in Germany. So the same resources are populated on or hosted on all these servers that are all around the world, that just make it more efficient to receive the content. All right. Next up is databases. That is a whole thing in its own. Um, for this topic, or for this room, what we need to know is web servers use databases to store information for their users. That way they can store and recall the data. Um, Databases can be extremely simple, or they can be clusters of servers. Like, databases can get extremely intensive. That's why there are so many jobs that are just around database administration. All right. Some common databases that you should know about: MySQL, MSSQL, MongoDB, Postgres, and each one kind of has its own thing going on with it, all right? And then finally, the last component we're going to go over is a web application firewall. That's what WAF stands for, and that sits in between your web request and the web server. So its primary purpose is to protect the web server from hacking or denial of service attacks. So it analyzes web requests for common attack techniques. That way, it can discern if it's an actual person requesting versus a bot. It might be doing rate limiting, where it will only allow a certain amount of requests per IP per second. That way, it's not saying, okay, this person just sent me 2,000 requests within 3 seconds. That seems crazy. Are they just trying to flood my resources here? The web application firewall can look according to its logic and then deny packets from even reaching the load balancer. So the load balancer doesn't have to deal with that stress. So web application firewalls, you might have to tune them. They're very useful when set up properly. Now we have three questions here. The first one is, what can be used to host static files and speed up a client's visit to a website? That's going to be our content delivery network. And you might say, okay, well, speeding up clients' visits to a website, load balancers can do that because they're making sure that the server that's responding to the requests has enough bandwidth, enough resources to properly, you know, deal with that connection. But the main clue here was the host static files. So content delivery network. And what does a load balancer perform to make sure a host is still alive? That's going to be the check that it performs on the servers, which is a health check. All right, and nothing too crazy about that. And what can be used to help against the hacking of a website? That's going to be that web application firewall. Okay, guys. All right, going on to task three: how web servers work. All right, so a web server, simply put, is software that listens for incoming connections and then utilizes HTTP protocol to deliver web content to its clients. It does not need to be a giant web server up in a data center. It could be a laptop, okay? Um, you don't need a lot to serve web pages. You really just need it to be properly configured. Some common web server software that we come across is Apache engines, uh, ISS, and Node.js. Two of those, excuse me, Apache engines, those are Linux based. ISS is Windows based. They have different default saving locations. So this one right here, the var www html directory, that is the default locations for Linux operating ones, while ISS uses on the C drive typically inet pub slash www root. All right, that is good to know when you are trying to gather as much information about a target. So being able to figure out from where a file is being hosted to from, just by looking and saying, okay, that directory is not Windows based, so it's probably not going to be ISS or IIS. Okay, it has a directory that looks like this. All right. So just by this information that we have right here, we're going to probably think it's Apache or engines. All right. One of those two. And if I'm pronouncing that wrong, too bad. That's just how I say it. All right. Next up, virtual hosts. So web servers can host multiple websites with different domain names, and how they do that is through virtual hosts. So the web server software checks the host name being requested from the HTTP header and matches it against the virtual host. So it's just whatever configuration files that has, and if it finds a match, it will provide a website that that header is asking for. If it doesn't match, the default website is going to be provided. And virtual hosts can have their root directory mapped to different locations on the hard drive. So if you have one virtual host serving up 1.com, another one serving up 2.com, they can be mapped to different directories. So var www website under tag 1 versus var www website under tag 2. All right. So you have the ability as an administrator on the server to properly allocate resources as you deem there. And there's no limit to the number of different websites you can host on a web server. Next up, We're talking about static and dynamic content. So stat content is content that doesn't change. So that's going to be pictures, JavaScript, CSS, some HTML as well. Um, so they are directly served from the web server with no changes to them. There's still a lot of it around on the internet. A lot of more modern websites, though, have a lot of dynamic content. So this content that can change with different requests. So blogs, your YouTube front page, Amazon, all that. So based on, you know, what the algorithm's showing you, so what is YouTube suggesting you on your homepage, if a blog updates what what's been uploaded, it might show you the latest entry and things like that. So dynamic, it's not static, it's moving, it can be fluid and things like that. And the changes that you end up seeing are called in the are the changes to what you end up seeing are done in what's called the back end. And that's what uses the programming and scripting language. And it's called the back end because it's what's being done behind the scenes. So you can't view the website's HTML source and see what's happening on the back end, while the HTML is the result of the processing from the back end. Everything you see in your browser is called the front end. So you being the client, when you open up your web browser, whether it's Chrome, Firefox, wherever it may be, you are seeing the front end of a website. The back end could be, the databases, the JavaScript that's running, all this stuff in the background that, like, you can see JavaScript from the front, but it might, I guess that wasn't the best example, but everything, all the processes that are actually being done from the programming is on the back end of it, all right? So just know the difference between front end and back end, all right? Back end simply on the server side, front end is going to be you at the client side and what you see through your browser. All right, scripting and back end languages. So there's not much of a limit to what a backend language can achieve, and these are what can make a website interactive to the user. Some examples of these languages are PHP, Python, Ruby, Node.js, Perl, and there's more too. And these languages can interact with databases, they can call external services, process data from the user, and so much more. A very basic example of PHP would be if you requested this website right here, which is example.com/index.php. Then we have a question mark, name equals Adam. So if the PHP was built something like this, which, excuse me, you have this HTML tag, you have the by tag, hello, then you have the actual PHP language right here, where it's called on PHP, echo get variable of name, and then it's going to close itself out and then closes by an HTML tag. So that's what on the back end is really going on there. And on the front end, what we see is this hello Adam, because the Atom portion that was probably passed either in a cookie or something where you pass the fact you logged in as Atom. So you won't see on the page it say hello with this PHP um, string right here. No, it's hello Atom. So you'll notice that the client doesn't see the PHP code because on back end, their inactivity opens up a lot more security issues, though, for web applications that haven't been created securely, which honestly gives people in our field both heartache, but it also is an avenue to have a career in. All right. So what does web what does web server software use to host multiple sites? That's going to be the virtual host. All right. And what's the name for a type of content that can change? So it's not static, it's opposite, it's that dynamic. All right. And then does the client see the backend code? Yay or nay? We're going with the nay because the client is typically what you see in front of you. They don't. So we have a quiz coming up. So we have 11 tiles here, and it's kind of putting together everything that we've done from the previous four rooms, putting them all together. It is the correct order of how to request a website, starting from the beginning all the way down. All right, so there's 11 things. You guys can take your time on it. I'm going to go ahead and start. If you get it right in the area, then it'll turn green. If you don't, then it turns red. All right. So let's see if I can drag this down. Okay. So I start off with the first thing is you as a client, you're going to request tryhackme.com in your browser. All right. Because you're not dealing with DNS or anything yet. You're in Google Chrome and you want to go somewhere. From there, I put at the very end, your browser is going to render the HTML into a viewable website because that's the end state here. All right, so we need to figure out everything in between now. So, what we're going to do is we are going to first try to resolve the IP address. All right, or we're dealing with DNS to see if we know what it is. So, first we check locally. So, we're going to check our local cache for the IP address. If we cannot find that, we want to go to our ISP to check out the recursive DNS server for the address. If we still don't got it, we need to then query a root server to find the authoritative DNS server, in which case the authoritative DNS server advises the IP address for said website. All right. Next up, we want to, let's see, where are we at here? Once we have it, we're probably going to, before the load balancer, so we have the server stuff, we have a load balancer in front of it, we have a web application firewall that's protecting the load balancer before any of the processes. So we're going to go web application firewall to load balancer. All right, so we got three of them now. And I'm going to say, let's see, the web application is probably a little bit later. All right, so we only got two. We need to either connect to a web server on port 80 or 443, so either through HTTP or HTTPS, or we can go with the web server receives a GET request. So before we get to the web server to have it receive its GET request, we're going to connect to it using HTTP or HTTPS, and then we'll go ahead and put that last piece of that puzzle in there. We got our flag right here. TryHackMe, you got the order. So hopefully you guys got it as well. If not, don't worry about it. All right. Just slow down, revisit what you didn't get in the right order. Take a step back. Don't worry about it. Everyone goes at their own pace. Okay. So we're going to go ahead and submit that. And if that goes through, congratulations. We have now completed putting it all together. Personally, this was like the fourth time I've had to record this because I just had a hard drive fail. So I'm very happy to see that the recording actually went through. And with that, we also have completed the World Wide Web module. So give yourself a pat on the back for that. And I'll join you in the next one where we start having real fun. We're going to Linux fundamentals. All right. So I'm excited for that. Hopefully, you guys are as well. Thank you all for watching. Have a good one.